Welcome to today's lesson. Today we're going to look at surface area, how to calculate for the surface area. But we'll look at the surface area for like 2D object and then 3D. So we look at something like the surface area for a rectangle and then square, rectangle and square together. And then we look at triangle. This would be like two-dimension figures. And then for the three-dimension figures, we look at the surface area for a cone, surface area for a cone, and then we look for a sphere, then we look for like a pyramid. Yeah, so this will be what we will look at, the surface area for rectangle, triangle, cone, sphere, and then pyramid. So that is what we'll be looking at. But before we look at that, let's first of all look at what at all is surface area. What does surface area means? I thought, okay, I thought I could add a page, but I'm using a different app. So what does surface area mean? So what is surface area? So like surface area. So basically, what does area means? That's area means. That's area means. Just have to pause here. Okay, so let's look at what an area is. So if you talk of an area, area is the space occupied by an object. That is the area, surface area that we are talking of. So the space that is occupied by an object is the area. So for instance, if I have this, let me just put any random objects here. Okay, so this is just a sketch, a random object. So the space, this space that this object is occupied is the area of this object. So like if I have this, the space that this occupied is the area of the object, right? So if you talk of surface area, you are talking of the space that an object occupied. The space that an object occupied. So I'll just measure the space and just measure the space, and then that will be the surface area for this object. So if I have this object here, I want to know the area of this object. It is this space that this object occupies. These are just randomly objects, but if we put regular object there and we know. So like I said, we're going to look at the area for a rectangle or square, triangle, cone, sphere, and pyramid. So the space that these shapes will occupy is the area. And then there is a formula that we will use to do that. So the first one we're going to look at is rectangle and square. Okay, let me first of all do square. Rectangle and square are similar. The only difference is that square have the sizes the same. All the sizes of a square are the same, and the sizes of a rectangle, two opposite sizes, the opposite sizes are equal. So let's see if this is a square. I'll try my best to draw to scale. I'm not drawing to scale, so don't. Okay, it's not perfect, but let's take this is a square, so all the sizes are equal. But if it comes to rectangle, opposite sides are equal. I think this is something that you know. Ooh, I need to clean this one. Oh my gosh. The reason I'm using the pen I'm using, I need to get a proper app for this thing. I could do that, but so let's say that it's not drawn to scale. It's not perfect. So this is a square and this is a rectangle. So that is a square and that is a rectangle. So this is a square and this is a rectangle. I hope you know the difference between a square and a rectangle. They have all the sizes equal and then opposite sides are equal. All the sizes equal for square and opposite sides are equal for rectangle. So we can label them. So because all the sizes are equal, we could say they are all the length, the length, the length, and then the length. The length. So here we can call the longer side as the length and then the shorter side as the width. So, but how do you know the area? We talk of area as the space that is occupied. So this space, that is the area of the square. And then this space, that's the area of the square. Let me put another square here. I'm very bad at this thing. I guess they should, if I'm using the other app, I think I should get some shapes. Okay, yeah, there you go. So this is a square. And then let's see if I can make this a rectangle. And this is a rectangle. Okay. So this is a square and this is a rectangle. So let's say this square have 2 meters by 2 meters, and then let's say this one 3 meters by, these are not drawn to scale, so by 5 meters. So I see the measures of the square. So what I could do is, if this is 2 meters, let's say if I divide the square into 2, then I'm having 1, 2, 3, 4. So the area this square is occupying is 4 units. That is 4 meters. Close. Yeah. But if I come here, I divide this part into 3, 1, 2, and I divide this part into 5. 1, 2, 1, 2, 3, 4, 5. It should be equal. It should be equal. I'm sorry I'm not able to put it to scale due to the pen that I'm using. I need to get a very big screen that I can do this thing, but I'm very sorry. It should be drawn to scale, so they are equal parts. So I'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area this one will occupy to is 15 meters square, because I divided it into 1 meter, 1 meter, 1 meter for 5 meters and then 3 meters. So I got 15 meter square, and I did the same thing. So this tells me that with this I can get that formula. With this I can get a formula for the square and then the rectangle. So what I can do is that then the area of the square is going to give me the length times the length. The length times the length, which is going to be 2 times 2, which is 4 meters square. And then the area for the rectangle is going to give me the length times the width, which is 5 times 3, which will give me 15 meters square. Always make sure you put your units there in meters square, because that is very important. That is very important. So 4 meters square, 15 meters. So in this, with this one, we can conclude and say that area for a rectangle is length times width, and area for a square is length times length. Length times length. Let's see more example here. Where did I get these figures from? Let me see. I have the square. So let's see, I have these figures here. Let's say this is 3 meters and this is 3 meters. This is 2 meters, and let's say this is 6 meters. So if I want to find the area of this figure, this is a square. So I know that the area of a square is A is equal to L times L. If I look at it, what is my L? My L is 3. My L is 3. So it's equal to 3 times 3. And 3 times 3 will give me 9 meter square. 3 times 3 will give me 9 meter square. But if you come to the next figure, which is a rectangle, and I know that the area for a rectangle is equal to L times W, length times width. What is my length here? This is my length, 6. So my length is 6 times my W, which is 2. So I'll get 12 meter square. 12 meter square. That's square. So I want you to pause and then look if you can find the area for this is 4 meters and this is 5 meters. Find the area for this rectangle with 4 meters and 5 meters. So pause and then do it. After that, check to see if you get it right. So your answer is going to be, okay, I hope you got it right. Let's see. So A, there's a rectangle. So rectangle is going to be length times width. Length times width. And then your length is 5. Your width is 4. So you get 20 meter square. 20 meter square. So that is what you get for. So for area for a square and then a rectangle is just multiplication of the length and length for square and then length and width for rectangle. You make sure that you check the unit and then you square the unit as well. If they don't have the same unit, then you have to convert them to one unit. If they don't have the same unit, you have to convert them to one unit. One unit. So now let's look at triangle. Let's look at triangle. So this is a triangle. Triangle is just half of a rectangle or a square. If you put a diagonal line through, like let's say this is my square or rectangle, and then I put a diagonal, I cut it across diagonally, I get two triangles. So this is a triangle and that is also a triangle. So it is simple. So triangle, because of that, is just half of the rectangle or half of the square. So the area is going to give you half base height. So we call this side the base of the triangle and this side the height of the triangle. This becomes the base of the triangle and this becomes the height of the triangle. So a triangle area is going to half of base times height. Base times height. So if you have any triangle, you only use this formula to calculate for the area. Formula to calculate for the area. So let's see some example. So I have this triangle which has a base of, let's say, 5 meters, and then it have a height of 4 meters. The height is perpendicular height. The height is the perpendicular height, 4 meters. So what I can do to find the area of this triangle is going to be area is equal to half of the base, half times the base times the height. Half times the base times the height. So area is equal to half times 5 times 4. Half times 5 times 4. So what is half times 5 times 4? What is, let's do half times 4 times 5 first. 4 times 5 will give you 20. And then half of 20. Half of 20, meaning divide 20 by 2, or half times 20. Then you get your 10 meter square. Always remember your units in meters squared. So that is it for triangle as well. That's it for triangle as well. So now I'm going to put some questions down. I want you to try your hands on them. I want you to try your hands on them. I'm going to put some rectangles, square, and then I don't have a shape for triangle. I'm going to put and then a triangle. So let's say this is 3 meters, this is 7 meters, this is 4 meters, and this is 4 meters. This is 4 meters, and then this is 6 meters. So try your hands on these three find the areas of these three figures: one rectangle, two triangle, and then a square. Find the area. So you can go back to the video and then see how to find the areas of them. Okay, so I want you to do this one. So let me give you a gist. So area of a rectangle. Area is equal to length times width. That is for rectangle. Area is equal to length times length, and that is for a square. And then area is equal to half base height. That is for a triangle. So use this to solve these questions, these three questions. To solve these three questions. So now I hope you can solve these three questions now. We're going to move on to like three-dimension figures like cone. We're going to move on to cone, and then sphere and pyramid. Cone, spheres, and then pyramid. Cone, spheres, and pyramid. Okay, so let's look at cone. Cone. You all know what a cone is, like Christmas cone. And then yeah, so this is the shape of a cone. A cone look like this. I'm trying my best. So this is how a cone will look like. And then it have the vectors here, that is the apex where they meet. Have the vectors here, and then this one is the what is called slant height. This is the slant height, and then this is the circle. The base of a cone is a circle. Then you know from the center of a circle to any part of the circle, to any part of the circumference is the radius. So this is a cone, and then you get to know the part, and then like the whole the circle is the base. That is the base. So that is what you need to know about cone, and then you need this to do it. And then we know that cone is a three-dimensional figure with a circle base and a curved lateral surface that extend from the base to the apex. So that is a cone. The three-dimensional figures with a circle as the base, and then it have a lateral surface that extend from the base, and then they meet at a point. Then they meet at a point. And then the height of the lateral surface become the slanted height. Slanted height. So this is what you need to know. So the shortest slanted distance from the edge of the base of the cone or any pyramid is its highest point. So that is it. And then the lateral surface, the surface that joins the two bases of the three-dimensional object, or that joins the base of the highest point. Yeah. So that is it. So now how do you know the area of this cone? The area of this cone. So if you consider this cone or any cone with a slant height and then a base radius, then we can look at it and construct the get the area from it. So let's see, as we have this in mind, let's see. Now let's draw another cone here. Let's draw another cone here. This is not perfect, but Let's take it like that. So this is the vectors of the cone. This is the vectors, and then this is the slant height. Let's call it S. Let's call the slant height S, and this is the radius R. This is the radius R. And we know that the base is a circle. We're trying to get the area of the cone. So we know that circumference of a circle, that is the distance around the circle. Like the circumference of a circle is 2 pi r. We know that circumference of a circle is equal to 2 pi r. So we know that. So let's try to draw the net of this cone. So if I'm trying to draw the net of this cone, if I should cut this cone open, I'm going to have a circle. This will be the base with a radius, r, and I'm going to have a lateral these are not drawn to scale, but forgive me. Yeah, and this will be the area, lateral area. You know, if I cut this open, if I cut the base, I'm going to get this base, and then if I open up this one, because so this will be the slanted height, and because it came together. If you get any cone, or even you can use a paper to make a cone, and then you see, and then so this is how it's going to be. So this will be the slant height, that's slant. So this will be the net, and then we know that circumference of a circle is 2 pi r. 2 pi r, and then that's the lateral area. So now from the lateral area of the net, if you look at this lateral area of the net, we can construct a large circle using the vectors and of the cone as the center and the slant height of the cone as the radius. So that is what we can get, as you could see over there. So we can get something like okay, let me just could do something like this. Yeah, and then so this becomes the radius of the circles, and then I now have a circle. Now the circumference of a circle is 2 pi r. We know that circumference of a circle is 2 pi r. So to determine the, and then we know area of a circle is what? Pi r squared. Area of a circle is equal to pi r squared. Area of a circle is equal to pi r squared. So now we have the lateral area over the larger area will be the same as the circumference of the cone over the circumference of the large circle. And the circumference of the cone over the circumference of the large circle. So let me put this once here. Hope that is going to let me. So this is the lateral area of the cone that we had. as I did it on top there, but I'm doing it separate here, and then I extended it to have a larger circle. This is S, this is S, this is the lateral area, just as I demonstrated it over here. This is the lateral area. So now we know area of a circle is pi r squared. Circumference of a circle is 2 pi r. Circumference of the circle is 2 pi r. So now we can say that the lateral area of the cone over the area of the larger circle. So we're trying to deduce it from the lateral. I'm using LA for lateral area. Lateral area of the cone over the area of the circle. Area of the circle is the same as circumference of the cone over the circumference of the circle. So I'm going to get, this part is going to give me 2 pi r over 2 pi s. 2 pi r over 2 pi s. That is what that is going to give me. And now, if you look at the area of the cone, which we don't know, but we're going to know it very soon. We're going to get it from our deduction very soon, which we don't know. LA of cone, lateral area of the cone over area of a circle, we know that is pi s squared. We are using s squared because now our radius is the slant height s. That's why we are using x squared instead of r squared. So we know this one, 2 pi can cancel 2 pi out. Over here, 2 pi can cancel 2 pi out. And then 2 pi will cancel 2 pi out. So we're now going to have the lateral area LA of cone over pi x squared is equal to r over s. Is equal to r over s. So now with this, with our algebraic knowledge, then we can say lateral area of cone is equal to r over s times pi x squared. So we can now do some cancellation here. S will cancel one of the s, and then we're going to have pi r s is equal to lateral area of the cone, LA of cone. So we get the lateral area of the cone. So with this deduction, we know that the lateral area of the cone, so that is just this part of the cone, the lateral area, that is the top part of the cone. So the lateral area of the cone can be calculated as pi rs. R is the radius, s is the slant side. Now if you want to know the total area, because we know that the base of the cone, so base area of cone is equal to, it's a circle, so that will give us pi r square. The base area of the cone is pi r square. The base area of the cone is pi r square. So if the total area, the base area is pi r square, the lateral area is pi rs, so the total area is going to be pi r s plus pi r square. That is the lateral area of the cone plus the base area of the cone plus the base area of the cone. So that is how to get the formula for the area of a cone. I know this is too much, but take your time, look at it over and over, and then you get it. But at the end, this is what we are looking at. This is what we are looking at. So all that we're saying is area of a cone is equal to lateral area plus base area. And then we know that the lateral area is pi rs, and then the base area is pi r squared. And that will give you the area of a cone. So if you are asked to only find the lateral area, then you know that you are only using this formula. If you are asked to find the base area, it's a circle, so you're just using this one. So you only need to know the slant height and then the radius. So you need the slant height and then the radius. Let's look at one example. Let's work out one example. A right cone has a circular base with diameter 27 centimeter and a slant height of 40 centimeters. Calculate the surface area of the cone to the nearest thing. So let's draw that cone that we're talking about. Said it has, that cone has a slant height of 40 and then a diameter. So this is diameter, this will be the center, 27 centimeters. This D is equal to, and then from here to here, which is 40 centimeters, our slant height. 40 centimeters. Note that our formula, surface area of a cone, surface area is equal to pi r is plus pi r square. Pi r is over pi r square. But what we were given in the question was a diameter. And then we know that diameter is equal to 2r, because radius is from the center to the circumference, and then the line that passes through the center from one circumference to the other passes through the center is the diameter. So our radius is equal to d over 2. So in this case, our r is going to give us 13.5. So we don't use 27 because 27 is diameter, and then the 27 is diameter, but we're looking for radius, so we have to divide by 2 to get 13.5. So all that you do is you put it in the formula. Then we know that pi, you can get pi on your calculator, or you do 3.14 is pi. 13.5 pi r 13.5 times 40 plus pi 13.5 square. 13.5 square. And then you put in the calculator to do it, and you're going to get 2269.015 centimeters square. So that becomes your area of the cone. That becomes the area of the cone. So that is how you find area of a cone. Just note the formula. That is the important thing. Unless you are asked to prove or you want to show somebody how it came about, that is where you go through all this process to prove it. Just I wanted you to understand how it came about. That is why I went through this. And then if you know how it came about, you'll be able to do it too. And then even if you forget the formula, you'll be able to show how it came about, and then you will get it. That's how I always want my students to know the how of the formula, so that even if you don't have to memorize the formulas, but if you know the how, then you know. So in conclusion, you know that this is a cone. It has a base area, so the base area is pi r squared, and then it has a slant, a lateral area, and then the lateral area, we know that it has slant height, and then that is pi r s. How do we get it? Because if you compare the slant height, we make it into a circle, and then we compare it, so this becomes the area of the cone. This is s, and then this is r. This is r. So that is it for a cone. I'm putting down one example for you to try. Putting out one example for you to try. So now sketch this here example to try. Sketch a right cone with diameter. Take note, it's a diameter, not a radius. 16 centimeter, and a slant height 12 centimeter. And then what is the area? What is the area? Or let me put it, what is the surface area? Let me do, what is the surface area or total surface area? So what is the surface area? So this is the question for you to try your hands on. So what you need to do is you draw the cone, you put a slant height there, you put the diameter there, but the formula is radius, and then you use the formula to calculate for the area. So try this and let me know what you get. Try this, let me know what that's the formula you use. Okay, so our next one is going to be sphere, surface area of a sphere. So we'll look at that one too next time. I hope it will come up soon. Thank you.